is number 3, and the formula you're given is PCl3. So again, I'm always going to do the same format for my math. I'm going to write the element, and I'm going to include any subscripts in the formula. I'm going to identify the period that the element comes from. Again, I just find that on the periodic table. And then I'm going to write a V for valence and a P for probable. So since phosphorus is in column 5A, I know it has 5 valence electrons. And since chlorine is 7A, I know it has 7. Multiply that by 3 because of the subscript. You always multiply by the subscripts. And then I add those two numbers together, 5 and 21, to get a total of 26 valence electrons that have to be shown. Remember, this is my actual number. To get the probable, remember, you're going to use the chart on the front of the paper. You will always have this chart. You do the same thing, but you identify the group and then look on the chart and figure out the probable number of electrons used. So a 5A element is probable to use 8 electrons, and a 7A element is also probable to use 8. Same idea, you multiply by any subscripts that exist, and then 24 plus 8 gives me 32 probable electrons. To calculate the probable number of bonds, I take probable electrons minus actual electrons divided by 2. And again, I'm always going to divide by 2 because there are always 2 electrons per bond. And when I do that math, I figure out that my structure most likely will have 3 bonds. The last thing I have to figure out is which one is central. Again, you look at the 2 elements, phosphorus and chlorine. You figure out which one is closest to carbon, which in this case is going to be phosphorus. So I know my phosphorus is going to be my central atom. I'm going to move that up a little bit. So after I figure out which one's in the center, I do that. I just write that one in the center atom. And then I figure out the best way to attach 3 chlorines with 3 bonds. That automatically tells me they probably should be single bonds. So I'm going to put 1 chlorine on each side. And then for the third chlorine, it really doesn't matter if it's at the top or bottom. It just matters that you put it somewhere in that location. So I figured out I have 1 phosphorus showing, 3 chlorine showing, and 3 bonds. So all of those things check out. The 3 bonds worked. Last thing I have to look at is that I'm showing the correct number of valence electrons. In this case, I have 6 bonds, so I'm sorry, 3 bonds showing 6 electrons. That is not enough. I am missing 20. So when that happens, you fill in or you show the remaining valence electrons using dots. And where you put the dots has to do with the octet rule. Remember, the octet rule says that each element wants 8 valence electrons. So right now, I'm looking at chlorine on this side, on the left side, and chlorine only has 2 electrons touching it from that bond. So I know that chlorine is going to need an extra 6 electrons. And just like when we did Lewis dot structures, I do that by adding dots. I'm going to go ahead and do that to every chlorine in order for them to have an octet of 8. So right now, after I add these dots, each chlorine atom now has 8 valence electrons. But if I look at my phosphorus atom, it has 3 bonds attached to it. It only has 6. So it actually needs 2 more as well. And I'm going to put those the opposite side. Remember the 4 corners, the opposite of the chlorine. And when I go ahead and I count all my electrons, I should get 26. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then the top on the 2 give me 26. So there's my structure for PCl3.